This session is a continuation of the Chapter 3 review with Problem 8. In Problem 8, we have a slightly different situation than we had with the previous problems. Here we have an x expression, and here we have an angle. These two angles are alternate interior angles, so if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. Therefore, these angles must be equal in measure. So, for problem 8, 6x plus 32 equals 116. Now we subtract 32 from both sides. 6x equals 84. And then we divide by 6. So x equals 16. Now we do the y. Now in this case, this angle and this angle are linear pairs. We know that these two angles are congruent, so this angle is equal to 116. So since these are a linear pair, this angle plus 116 is going to equal 180 degrees. So 5y minus 21, this angle, plus this angle, 116, again because these two are congruent, equals 180. So now we can combine our terms on this side. Oops. 5y plus 95 equals 180. Subtract 95 from both sides. 5y equals 85. Then divide by 5. So y equals 17. And now on to problem number 9. In this set of 4 problems, the instructions are find the value of x that makes m parallel to n. So in problem 9 here we have two consecutive interior angles, and the consecutive interior angles converse theorem says if two lines are cut by a transversal so that the consecutive interior angles are supplementary, then the lines are parallel. So for m to be parallel to n, these angles have to be supplementary, which means they have to add up to 180. So, for problem 9, x plus 73 equals 180. So now we just subtract 73 from both sides, and x equals 107. Now, problem 10. In problem 10, we have two alternate exterior angles. If two lines are cut by a transversal so that the alternate exterior angles are congruent, then the lines are parallel. That is, the alternate exterior angles converse. So these two angles have to be congruent, which means their measures have to be equal. So for problem 10, 147 equals x plus 14. And so subtracting 14 from both sides, 133 equals x. And now on to problem 11. In problem 11 we have a little bit different situation. There's an internal angle here and an exterior angle here. There's no direct relationship to these two, but we can infer a relationship based on these positions. We know that this angle and this angle are corresponding angles. So if n and m were parallel, these corresponding angles would have to be congruent. If this angle is 2x plus 20, let's go ahead and write that in. So this angle would be 2x plus 20. Then these two angles are a linear pair, and these two angles would then be supplementary. So they would both add up to 180 degrees. So let's go ahead and use that fact. And so for problem 11, we're going to have 3x plus 2x plus 20 equals 180. Let's go ahead and combine our x terms. So 5x plus 20 equals 180. Then subtract 20. 5x equals 160. And divide by 5. X equals 32. And now on to problem 12. Problem 12 is a little bit more straightforward. That's all we have is two corresponding angles. So the corresponding angles converse says if two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. So this measure is equal to this measure. So for 12, 7x minus 11 equals 4x plus 58. Let's go ahead and combine our x's on the left side. So subtracting 4x, we have 3x minus 11 equals 58. 3x equals 69. And x equals 23. So we added 11 to both sides to get 69, divided by 3 to get 23. That takes care of 12, and now on to problem 13. In this group of 4 problems, we're going to have a different situation. We're going to have to do some analysis based on our theorems involving perpendicular lines. Here it says, determine which lines, if any, must be parallel. Explain your reasoning. So let's go to problem 13 here. We can see that y is perpendicular to z and x is perpendicular to z. So there's a couple of ways we can do this. We have two lines perpendicular to the same transversal. That's the perpendicular transversal theorem. If two lines are perpendicular to the same transversal, then those lines are parallel. We can look at it in a slightly different fashion as well. We can go back to some of our older theorems in that we have two lines that are perpendicular. If two lines are perpendicular, they intersect to form 4 right angles. That's the 4 right angles theorem. Let's pick a different color. So this is a right angle, that's a right angle, and that's a right angle. Same thing here. All these are right angles because this line is perpendicular to this and this to this. Now we have a situation where we have two lines cut by a transversal, and we can use any one of a number of angles. This angle and this angle are right angles, so they're congruent, and these are corresponding. So if two lines are cut by a transversal so that the corresponding angles are congruent, the lines are parallel. We have alternate interior, alternate exterior, and we have consecutive interior that are supplementary. So by any one of the 4 converse theorems, we know that these two lines are parallel. So in 13, we can say, oops, let's go back to our white chalk. So in 13, we can say line X is parallel to line Y. And that's all we can say for 13. Now on to problem 14. Now in problem 14, we have an interesting situation. We have Z is perpendicular to X and W is perpendicular to Y. Now we might be tempted to say that X is parallel to y or that w is parallel to z. But if we actually look at what's going on here, let's take a look at this picture down here. Now, as it turns out, what we have is y and w are linked because they're perpendicular. X and z are linked because they're perpendicular. If we were to draw this slightly off center, we would see that without violating the conditions, we could rotate y and w and exaggerate the relationship between those and x and z. And we can clearly see that without destroying the fact that w and y are perpendicular or that z and x are perpendicular, clearly you can see that w is not parallel to z and that y is not parallel to x. So it's an optical illusion. Even though they appear to be parallel, there's no way we can prove that they're parallel with the information that we're given. So our conclusion for problem 14 is no lines are parallel. We'll just write none. And now on to problem 15. In problem 15, we have several active relationships. Here, line M and N they're perpendicular to line A, so two lines perpendicular to the same transversal, those two lines are parallel. So we know, first of all, in 15, line M is parallel to line N. And then also we can see that line A and line B are perpendicular to line N. Now because of this, again, we have two lines perpendicular to the same transversal, so line A is parallel to line B. Now if we take a look at line L is perpendicular to line B, and line N is perpendicular to line B. So again, two lines perpendicular to the same transversal, line L must be parallel to line N. So we can say line L is parallel to line N. And now we have an interesting situation set up here. We know that line M is parallel to line N, and line L is parallel to line N. So we have parallel line transitivity involved here. So if line M is parallel to line N and line N is parallel to line L, then line M must be parallel to line L. So line M is parallel to line L. And now for problem 16. In problem 16, we have a slightly more complicated situation. Here we have line M, line N, A, B, and C. Line A is perpendicular to line N, and line B is perpendicular to line N. So again, we have two lines perpendicular to the same transversal, so we can see that line A is parallel to line B. So that's our first condition. Looking at line M and line C, they're perpendicular, but there's no linkage between the two, and we can see that if we rotate this, we can change the orientation so there's no linkage between M and N, so neither of those are parallel to either N, A, or B. And now on to problem 17.